Our whole universe was in a hot, dense state that nearly 14 billion years ago expansion started. Wait, the earth began to cool, the autotrophs began to drool, Neanderthals developed tools, we built a wall. We built the pyramids, math, science, history, unraveling the mystery that all started with a big bang. Hey!
Oh, why hello there, Global Studies students. So good to see you again. Welcome to class. Today, we're going to talk about the Big Bang Theory. Now, we've been talking about human origins, the origins of Earth, and even the universe so far in this unit. We've been talking about why we like to know these things, how the unknown terrifies humans, and how we try to explain the unknown through myths, beliefs, and theories. We have already looked at a few creation myths. Myths are stories just understood to be stories. We looked at a creation belief in the book of Genesis. And now today, we're looking at a creation theory in the Big Bang Theory. We'll also be using the textbook PowerPoint units here, and we'll see that this first one is focusing on humans in the universe, and this time span will cover 13 billion years ago to about 200,000 years ago. You will note beneath me, I have got the 12 steps on our note sheet. So if you don't have your note sheet out already from the 29th, please go back, open that up where you have the definitions of myth, belief, and theory. And we'll be adding on those 12 things today. So let's check this out. Here, we're going to get introduced to our PowerPoint narrator. Now, usually when he speaks, I'm going to ignore it and not at all read it or even address him. He says his name is Mundo. I think he looks more like a Globey. Therefore, for this class, I'm going to call him Globey. What's up, Globey? Yep, still talking. Okay, so questions we're going to be kind of addressing in this PowerPoint. How did the universe come to be? Where did our Earth come from? And how and when did we humans appear on Earth? Yes, Globey, they're deep questions. That's all right. So, all people have explanations of our origins. Here's a few examples of some myths or beliefs. Here, the Maidu people, native to California, say that the Earth starter made the world from some green slime, turtle which brought up from the deep underwater. He made humans from red earth mixed with water. And the Chinese say that Fan Ku, no thing, not yet born, burst from a hen's egg and became the great creator. All right, I'm going to pause the video real quick because I just got the spinning beach ball of death, which I'm sure many of you guys now with Mac products have encountered before. So let me fix that real quick. Just a moment. We back? Oh, we're back. Okay. All right, I got it fixed. I think, actually. There we go. Okay. So, scientists offer a different explanation based on evidence gathered from sources here on Earth and in space. Here's what they might say. Long ago, there was no time. There was no space. Like, no space. Yeah, I know. Hang with me here. But about 13 billion years ago, things changed. Bang! Okay, with the Big Bang Theory, that's kind of where we start here. We're going to start with step 1 here of the Big Bang Theory is going to be simply that. Bang. So go ahead and write that down, and we'll keep moving on. Alright, so where there had been nothing, now there was everything, the whole universe, tiny and fantastically hot. For an instant, it expanded faster than the speed of light. Then it slowed down, but kept expanding, and still is to this day. I know many people talk about the Big Bang coming from a singular point and then expanding out. I believe if you speak to scientists or people who study this, it's not necessarily like a singular point location that it started and expanded, but rather it was kind of defined as everywhere at once exploded and expanded, not a singular point. I might be misspeaking, so I'm just going to leave it at that. If you want to ask more, Ask someone else, I guess. Okay. So, as the universe cooled down, clouds of hydrogen and helium gas began to gather together, their centers getting hotter and hotter. And when they were hot enough, the hydrogen atoms began to fuse together with the power of millions of hydrogen bombs. Dang. And boom, stars were born. That is going to be number 2 on our note sheet. Stars are born. All right. All right, so stars being born is step 2. From there, they cluster together in vast galaxies, each containing billions of these new stars. No, we can't see us yet, Globey. Why? Moving on. 4.5 billion years ago, when the universe was still 2/3 as old as it was today, a star was born near the edge of the galaxy, which we call the Milky Way, which was our sun. If you look at the timeline beneath us, you can kind of see, I can't really highlight it, but you can see at the far left of the timeline, 13 billion years ago, Big Bang. And then over to the left, stars and galaxies born. And if you go way over to this green section right underneath the sun where it says our sun and planet, that was about 4.6 billion years ago. So in Big Era 1, we're already 2/3 of the way through, and all that we've had is a massive explosion, and the first stars are forming. Now, around the sun, wisps of matter were drawn together by the forces of gravity to create the planets of our solar system. So pretty, aren't they? Including the third rock from the sun, our Earth. Yay! Okay, so this kind of gets us to stage 3 here. Where's my cursor? There it is. Not necessarily our planet, but just planets in general in the Big Bang. They form next. So, planets form. I spelled plants. Let's try that again. Does that look good? Yeah, that looks good. This is fine because I'm stalling long enough for you guys to type as well, right? Okay. Okay, that's gonna bother me. Y'all see that little hyphen, how it's so tiny and small? Let's see if we can fix that, because it's gonna drive me nuts. Oh, it's not gonna let me, is it? Oh, there we go. Okay. All is well with the world. I know that this is what's pressing and important to you guys, right? Okay. So, planets form, particularly our Earth. Yay. Is that a really slow lag? Nope, spinning ball of death once again. All right, just a moment, please. All right, and we're back from my multiple crashes here. So, anyway, the early Earth was incredibly hot. In fact, it was just a liquid ball of hotness. Heavier metals melted and sank to the center, while lighter metals rose to the surface, and gases bubbled up to make the Earth's first atmosphere. So, step 4 of our list of things on the Big Bang is going to be atmosphere. All right. Hopefully these transitions are seamless for you guys, as my PowerPoint has crashed yet again. Oh, you can see it's even on the wrong page. Let's fix that. Okay, so this is where we left off. Moving on. Please move on. So atmosphere is formed. There we go. So by 4 billion years ago, the Earth had cooled enough for water to condense into oceans, and so the earth turned blue. So after atmosphere, step 5, water forms or water accumulates. So water accumulates. Absolutely fantastic. The surface hardened into thin plates floating on the molten materials underneath. And if you think about it, our understanding of the Earth is it's still that way to this day. While it's a molten liquid core, I believe, and layers of rock still float on top of that. This is kind of what I would like to draw a parallel to. Hang with me here. Nacho cheese. If you've ever worked a concession stand and you got that crock pot of nacho cheese and you take the lid off and all the moisture, the humidity kind of causes it to rain, and on top of the nacho cheese is the nacho cheese layer. It's starting to get a skin, a cheese skin, if you will. And quickly you take the ladle and you mash it up and mix it up to get it melted because it's kind of gross, but that's kind of our Earth. It's molten cheese inside, and the thin cheese skin form plates, large rocky exterior to the Earth, or nacho cheese. I forget what we're talking about. But anyway, so the surface hardens into thin plates, floating on the molten materials underneath. Those plates float on the surface to this day, constantly changing the landscape, the weather patterns, and Earth's surface. And it's true because if you think about the plates moving, if they push together, they would cause mountain ranges. And mountain ranges most certainly have an impact on weather patterns. Just look at the eastern side of like every mountain chain on Earth. Usually weather patterns go from west to east, and as they cross over, the east side is always a dry desert. Fun stuff, right? All right. So what? There, everything's awesome. Okay. So, where plates collide, great mountains were formed. Everything is so fantastic. And where they tore apart, molten rock poured out from under the surface, just like cheese. Deep within the newly formed oceans, complex chemicals were created using volcanic heat for energy. Some of these chemicals began so highly organized that they formed cells, the first life on Earth. And as you can imagine, these simple organized life forms, is it the next slide? No, it's not. Okay, so for this one, step 6 of our list of the Big Bang Theory is going to be single-celled organisms come about. Did I misspell accumulates? I totally did. So step 6, single-celled organisms begin. Thanks to the very hot temperatures and the energy given out from these volcanic vents deep within our oceans. Now, living organisms change the atmosphere, adding oxygen. Literally, these single-celled organisms are farting out oxygen, and that's what we breathe to this day. So then step 7 is going to be the creation of oxygen. That's going to be important. All right. Oop, wrong one. There we go. So cells developed that could breathe oxygen, because that's, useful, right? And about 600 million years ago, the first multicellular organisms arose in the Earth's oceans. So we went from having single-celled organisms farting out oxygen, and oxygen supporting larger life, such as multicelled organisms. So let's get that as number 8 on our list. Making sure I spell correctly here. Okay, so let's go ahead and pause for a moment and look at our timeline that way, down there. We'll see again on the far left, 13 billion years ago, Big Bang, stars and galaxies form, and then most of the history of the universe is just that. And then eventually, about 2/3 in, our own sun is created, then planets are created. First, life appears on Earth, and then in that little green section is just the presence of multi-celled organisms. And that's roughly 660 million years ago. And actually, we're in Big Era 1 right now. If you look at the very end, there's a thin line. Those are Big Eras 2 through 9 fit into that tiny, tiny sliver of a line on that timeline. All right. Moving on. The first animals appeared not long after. Now, after a while, some animals moved out of the oceans and onto land. Dinosaurs were the most successful of the early animals. So roughly about 220 million years ago, we get dinosaurs. Yay, dinosaurs. And about 65 billion years ago, dinos dead. So they're around for, just a little while. So 65 million years ago, dinosaurs die. That's too much. I'm just going to put down dinosaurs die. Dino's dead. Just like my will to keep on typing, right? And of course, the dinosaurs dying is going to leave the next phase of dominant life to come about, and that is mammals. So number 11 is the presence of mammals. Now, people always ask me about dinosaurs, mammals, how much of them live together. Could we have dinosaurs now? Anything like that? And the issue actually comes down to, we believe dinosaurs, because of the size of them, size of lungs, the amount of oxygen they would need to consume would have to come from very large plants. Very large plants, which we really don't have on this planet anymore. After this mass extinction event... Oh, did my video freeze? Oh, look at that. Everything is just doing peachy. All right, we're recording again. Okay. A lot of time might have passed. A computer might have crashed, but I'm back. Things are put back together, and the camera is only freezing a little bit. That looks awful, but I will carry on. So, mammals are here. Dinosaurs are dead. Even if we recreated them Jurassic Park style, I don't think they would survive. It does not seem like the atmosphere is not oxygen rich enough to support them. So, whatever. No one cares. All right, so mammals are here. Did we type? No, we didn't type that in yet. Let's go ahead and type that into our notes right now. Huzzah, mammals. So over time, a particular group of mammals emerged that lived in trees. Now, to survive in this environment, these mammals needed 3D vision and large brains to process visual information. They also needed hands that could grip with precision. Now, imagine living in a tree without any of these things. It would be rough. We would probably die. So these mammals were the first primates. And if you think about 3D vision, that's actually really important, not just for everyday life like what you and I experience. Let's say if you're a sporting event, it's probably important that you have 3D vision so you can see the depth of a ball so you can catch it or interact with other people. In fact, 3D vision is actually given to us because our eyes are on the front of our faces. If you look at some animals, maybe like a squirrel, I don't know why, but just imagine a squirrel if you've seen one lately. They actually have eyes on the sides of their heads pointing outward. And because of it, it gives them a full range to look around them on each side at the same time. But having two eyes in front that overlap but are slightly different will give us a third dimension, depth, to what we see. And if you think about it, everyone with glasses right now in the classroom or in your living room or wherever you're listening to this, you are actually not looking at the objects around you, but you're rather looking through the lens of your glasses. So people with glasses tend to lack good depth perception. Therefore, kind of the stereotype of someone who's wearing glasses isn't good at sports. It's not that they're good at sports, is that they really can't understand the depth of a ball moving towards them to react fast enough. As a person who switches between contacts and glasses all the time, I can vouch for people with glasses. It is rough to see. In fact, usually when I'm coaching sports like soccer, I'll wear contact lenses all the time so I don't get hit in the face. Right now, you guys have witnessed me wearing contacts all the time because I don't want my glasses getting fogged up because of masks. Otherwise, you guys would see me wearing glasses almost nonstop. But nonetheless, having eyes in the front of our heads, having hands and feet that can grasp things, really make it easy to live in trees. Getting the big brains, well, now we're just being modest, right? But that will come up later. We'll talk more about big brain later. Maybe. I don't know. No promises. So then, about 7 million years ago in Africa, a branch of those primates began the first to stand upright. These were the first hominids. Different hominids lived on Earth over the next 7 million years, some at the same time as others, but only survived to this day would have been us, humans, Homo sapiens. So hominids are upright bipedal, meaning we stand on 2 feet. And there's different species of hominids. It's kind of strange to think about because humans today, Homo sapiens, we're the only species of hominids left or descendants of. In the previous millions of years, we would have different versions like outside of Homo sapiens, there's like Homo erectus or Neanderthals and so forth. And they're all technically different species. And to our understanding, they could not mate with one another. Or if they did, it would be like a weird donkey situation. FFA students, I'm probably going to pause this so you can correct me here because I can never keep this straight. Like there's a horse and a mule, or is it a horse and a donkey? If they bump uglies and have offspring, they have either a mule or a donkey, and that is sterile. It cannot reproduce because it's a multi-species creation. Again, the biology people have to help me out here. Just believe me here. Now, of course, there are anthropologists and paleobiologists, whatever. They're different scientists, nerds, who actually think now, just these past few years, that by checking out all of our DNA, that we actually might have Neanderthal DNA in some humans, which means that, in fact, they could reproduce and they could have offspring that were, in fact, fertile and not sterile. But I digress. Number 12 on our list, humans. Humans have made the list. We are now welcome in the club. Humans. Huzzah. And that is step 12 of the Big Bang Theory. We are actually very relatively new to this whole thing known as, the history of everything. So the earliest hominids lived in small family-sized groups. Makes sense. They gathered plants, insects, and small animals, and they occasionally scavenged the meat of larger animals killed off by predators. So they were hunter-gatherers, they were nomads, they were nomadically wandering wherever they could find food. The first hominids had brains about the size of a modern-day chimpanzee's. Now, over time, new species developed ever larger brains, and they began to make more and more complex tools. Some of them arguably even use sharp sticks to dig for food. Now, people wonder, how do they just get bigger brains? A combination of different things. Of course, there's the concept of survival of the fittest, where just having a larger brain meant that you have better advantages. Better advantages means that you are more likely to reproduce. Those without those advantages, possibly less likely to reproduce. And over years, not like decades, but we're talking like hundreds, if not thousands of years, this accumulation of these benefits, mating, more likely to succeed and reproduce, those with less beneficial not succeeding as much. Over time, we see that change. Also, well, we'll get into more of that later, but there's also a concept with cooking our food, making it easier to break down food, because raw food is tough to digest. Cooked food, once fire is implemented, made it easier to digest, thus giving us more energy to do things and develop larger brains, but we'll get into that potentially later. Now, while Homo habilis hominids, a later species, were able to make stone tools, the start of the Stone Age or the Neolithic period. They chipped flakes of stones from large rocks and used those flakes as knives. They also used the leftover core to scrape out hides and do other jobs. Now, Homo erectus hominids, which lived on Earth for almost 2 million years, were probably the first ones who could control and use fire. This is where we're getting big brain stuff from. They were also the first to leave the continent of Africa. Their fossils have been found as far away as China and Java, the islands in the Indian and Pacific Oceans. Now, social relationships among our ancestors were complex. Like modern-day chimpanzees, we observe, based off the observations of chimpanzees, we believe early hominids must have been quite clever as well, with a great deal of social cooperation and group politics. Now, cooperation, I mean that they work together, and politics, I mean the earliest form of government, the idea of a leader and followers. They cared for each other, especially their children, because a lot of these children are very dependent. If you don't feed a baby, it's just gonna die. It's not like it's gonna crawl and find food. It doesn't move for quite a long time. So you would need to take care of your young for a long period of time, and chances are you would need help while doing so. Oh, and it froze again. Alright, ladies and gentlemen, I have no idea how many times this has crashed and I've had to restart. So let's just try to finish this up as quickly as possible. It's not gonna let me. It totally froze again. Okay, so in some ways that's true, but this species was different in many other respects from other species. We have no evidence, for example, that they had things like art, religion, or language. So these earlier people are not as advanced as you and I would associate like cavemen as being. So these are just upright bipedal hominids. So what makes us so special? Us humans. Thanks, Globey, because you're not human. I get it. All right. Anyway, Globey's back here, so I'm sure that's probably the end of the PowerPoint. Thank goodness. Okay, so we've got our 12 steps of the Big Bang Theory, so we can see the progression from the start to where we are today. That concludes this for now. Thank you for taking notes. I apologize for the technical difficulties, and hopefully I can get this resolved. Yeah. Have fun. Bye.